Okay, so do you see my screen? So yesterday we talked a little bit about some examples of two-dimensional motion. So I want to just today to continue this topic. So we have so basically motions in 2 or 3 dimensions. So I begin with two-dimensional motion. So for two-dimensional, so the position is a vector with 2 components, right? So R is the position vector. Position vector, I denote it by R, or sometimes I put like an arrow above it to emphasize that it is a vector. But if I don't put just it's a you should know by default this is a vector, okay? Which is equal to x and y. It has, because it's two-dimensional. So we do have the same thing for velocity and acceleration. So the velocity v is also equal to vx. So I denote the two components, xy components, by vx and vy. Okay. So now the question is, what is the, if you want to compute the average velocity, what is the average velocity? So the average, give me a second. So the average velocity is, as usual, equal to, so say v, I denote it by v, is equal to delta r divided by delta t. But what is delta r? Delta r is the change in position. So is r, I just put f means final position, minus r0. R0 is the initial position. So RF, this guy, is the final position, and R0 is the initial position. And what is delta t? Delta t is the time duration, which is TF minus T0. Again, TF is finite time, and T0 is the initial time. Okay? Is that clear? Yeah. So this is the average velocity. So if you want to see like a simple picture of this, so we have an object that moves in two-dimensional plane, and you have, like, imagine that this is the initial position and that is the final position. So I just say this is VF, sorry, RF, and this is R0. So here, what is delta R? Delta R is basically this vector, and V is also in the same, the average velocity. So the average velocity is also in the same direction of delta R, right? So V V average in the same position, in the same direction with delta R. Okay.
But for the position, when we calculate the vector, do we need to like the tail to tips, tail to tail, or tips to tail? Because why they just start in this?
Yeah, so we do whatever we do is vector operations. So let me clarify this. So R0 and RF, and in general R, are vectors. That means they have two components, X and Y. So when you want to subtract them, you get another vector with two components, like delta R. Okay. So here, delta R, if you want me to be more precise, is you can also say that delta R is basically equal to this. I mean, something like this, right? In terms of the two components of it.
What is R stand
for?
What does R stand for?
R stands for the position. So I denote the position vector. It's usually we use R for position. But it has two components, X and Y, okay? Okay, so V average is the same direction with delta R. I hope that this helps. Okay, now the next thing is the instantaneous velocity. So instantaneous velocity. So it's basically V limit of delta R over delta T when delta T goes to 0. If you know calculus, this is basically equal to dr by dt, the derivative of R with respect to T, the derivative of position. Have you ever heard about derivative? Okay, so I will tell you, don't worry. So it's basically the derivative of position with respect to T, but it's still a vector. So it's a vector. Okay, so in general, and I just to recall that whenever you have a vector like velocity, so imagine that the trajectory of a particle that moves in two-dimensional it goes like this. This is the trajectory of motion. So it's like a particle moves like this on the two-dimension. Trajectory means the points that the particles goes through in two-dimensional space. Basically the path. It's a technical term, trajectory, in math and physics. You have to know this. It means the path that a particle goes through, okay? So if this is the trajectory, so for example, at this time, at this point, the velocity is basically the tangent vector. Tangent means some line or some vector that is like tangent. It's exactly the shape that I draw. It doesn't cross the point. They meet at that point. Yes, exactly. So here is the difference. You see, when you have like a curve, So this line crosses the curve, or this line crosses. But this line, you can also say they cross each other because they meet at some point. But we say this type of crossing tangent. Okay, and I can tell you in terms of math what it means. What is the difference between this crossing and that crossing? And precisely in terms of mathematics. But anyway, so here is the instantaneous velocity at this point. So this is instantaneous v. Okay, so like any vector, the velocity has also two components. So you have the x component, so I just call Vx. And you have the y component, I call it Vy. And here you also have the angle between V, I call this alpha or theta. So theta is the angle between V and the positive direction of x. We usually measure angle with respect to the positive direction of x-axis. Okay, that's we do it normally. So what are the components? So we know that V is basically, it has two components, Vx, Vy. So the speed, so this is the vector, okay? This also is a vector. So the speed, that is the magnitude of V. So we denote the magnitude of V by the absolute value of V. This is equal to the square root of Vx squared plus Vy squared. And another thing that is useful is tangent of theta is basically Vy over Vx. So theta gives you the direction, okay? Whose tangent is Vy, the y component over the x component. Okay. Any question? Okay. Now, so we have this exactly the same thing for acceleration. Acceleration, but acceleration instead of delta r by delta t, acceleration is what? So average acceleration A is delta v over delta t. This is the average acceleration. And instantaneous acceleration, this is instantaneous, is dv by dt, the derivative. That means we let delta t goes to 0. So that means the passing of time is very, very tiny. That is basically the meaning of instantaneous, right? When the time interval is very small. Okay, so we have the same thing, concept for acceleration. Now let me give you a good example, and that is, so example, so we have a particle, the trajectory of a moving particle, so, or a moving object, is given by, so the trajectory, that means we give you x and y coordinates in terms of time t. So x of t is basically 2 minus alpha t square. I will tell you what alpha is, and y of t is equal to beta times t plus gamma times t cubed. So what are the constants? We have here three constants, alpha, beta, gamma, where alpha is equal to 0.25 meter per second square. And you can see why the unit of alpha is meter per second square. And beta is 1 meter per second. And gamma is 0.025 meter per second cube. So here I just want, so I could write like x of t is 2 minus 0.2 times t squared, 0.25 times 2 squared. Or I could write y of t is equal to t plus 0.025 t cubed. But here I did this because I wanted to emphasize the units. So the units of these constants are important. Can you see this? The reason? Okay. Okay, very good. So this is the trajectory. So here I want you, so A. So find, this is easy, find the position at t equal to 2 second. B, find the displacement. Displacement basically means delta R in our language. Displacement and average velocity in the time interval t equal to 0 to t equal to 2. These are seconds. And C, find the general. So the part C needs calculus. Find a general formula for instantaneous velocity. So usually in high school, when they do physics, they don't do the things that needs calculus. But since you are a very good and sharp students, we do it together. Great. Good deal? Okay, so let's do it. So you can, I'm sure you can do part A and B, and probably you can also do part C, but I will tell you. So let's try to do this. So what is the position at time 0? So R is basically the position is XY, right? So I can even show it in a picture. By the way, what is the position at the time equal to 0, t equal to 0? First, tell me this. What is the position at time 0?
0, 2, 0.
Okay, so here is the, you can say that this is the position R0. I just say R0 is equal to 2 and 0. Okay, now what is R1? Yeah, sorry. So let me just copy this. And we know that alpha is 0 point. Here I just put the value of alpha, which is 0 0.25, right? 0 0.25 times t squared. Beta is 1 and gamma is 0 0.025. So beta is 1, so it's t. And gamma is okay, so what is R1? So X1 is 2 minus 0 0.25, which is 1.75, right? What is the Y component? Yeah, it's 1.025. And then we have R2. What is R2 then? So the green line shows the motion of the trajectory of the moving particle. So these blue vectors shows the positions at certain times, like t equal to 0, t equal to 1. So x, t square is, oh yeah, x is 1. So R2 is equal to 1, and what? What is y? 2.2. Okay. Now, for part A, so the average velocity, so I say V average, VAV is equal to delta R over delta T, which is basically R2 minus R0 over 2, and that is equal to what? So what is, so delta R is, okay, so before that, let me just, this is a correct formula, but before this, let me just find delta R. So what is delta R? Delta R, this is the displacement that the question is talking about. So displacement delta R is R2 minus R1, which is equal to 1.1 and 2.2 minus, sorry, R0, not R1, minus 2 and 0, right? So this is minus 1 and 2.1, 2.2 meter. I mean, meter, each of the component is in meter. The vector is not meter, but each component. Now, what is the displacement? So this is the displacement. So what is the length of the, if they want you to find the length of the displacement, that is the magnitude. So what would be the magnitude of the displacement? So magnitude of delta R is exactly, so root 1 plus 2.2 square. So which, I don't know, so you can compute this with calculator. Okay, now it comes to the average velocity. Average velocity is delta R over delta T. So we know here, we just computed delta R. Delta R is 1 minus 1, 2.2 over 2. So it is minus 1/2 and 1.1. Right? Okay. So this is the average
Excuse me,
velocity.
sir.
Yes.
So how can you get the position of the R1 and the R2?
How can what? Sorry.
You find the position of the R1 and R2.
Yeah, but here we need the average velocity during the time 0 and 2. From 0 to 2. So that means
Yes.
delta R is R2 minus R0. We don't need to use R1.
Oh, okay.
Okay. I just computed R1 so that you can see how this particle moves. Okay. Okay, so this is the average velocity in the time interval from 0 to 2. So that is why I subtract R0 from R2 and then divide by delta t, which is 2. Now, the next step would be computing the instantaneous velocity. From the geometric point of view, the instantaneous velocity is the tangent vector at each point. So for example, at R0, the instantaneous velocity is like this. At R1, the instantaneous velocity is like this. At R2, the instantaneous velocity is like this. So it is the tangent line to the curve. And we can compute it by now this is the calculus part. Okay, so we can compute the instantaneous velocity using calculus, basically using derivative. So because R, let me just write R. R, the position is X and Y. So it has two components. The first component is 2 minus 0.25 t squared. The second component is t plus 0 t cubed. Okay, so the instantaneous velocity v, I just denoted by v, is equal to the derivative of r with respect to t. If you know how to take derivative that you learn basically in calculus, so the derivative of this guy, so this is x. So the derivative of x with respect to t, so I just write here on the top. So dx by dt because the derivative of the function t squared is 2t. So in general, if you have t to the power n, its derivative is n times t to the power n minus 1. Okay, so the derivative of t squared is 2t. So you just multiply 2 by 0.25, you get minus 0.5 t. And the derivative of y with respect to t, derivative of t is 1 plus derivative of t cubed is 3 times t squared. So plus 3. Now you have to multiply 3 by 25, you get 75. So you get 0.075 t squared. So that's the general formula for V. So dr by dt, its first component is minus 0.5 t. And the second component, dy by dt, is 1 plus 0.075 t squared. If you don't know calculus, that's fine, don't worry. But I can teach you how to take derivative, and you only need that, taking derivative, okay? Okay, so that is basically the instantaneous velocity general formula in different times. So now we can find, for example, what is the instantaneous velocity when t equal to 0? So for t equal to 0, v is equal to what? is 0, 1. You see in the picture, the red velocity at 0. So the velocity is vertical. I mean this guy. You see this guy is vertical. Is 0, 1. So if t, and we can compute it in different times. For example, if t is equal to 1, then what is v? You just plug in t equal to 1 into equation. So v is 2 minus 0.25 is 1.75, and 1 plus 0.025, so it's 1.020. This is basically this vector. So this vector, the yellow vector. And finally, if t is equal to 2, then v would be equal to what? Minus 1 and 4 times 75 is what? Yeah, 300. So exactly, so it's 1.3. So these are the instantaneous velocity at t equal to 0, t equal to 1, and t equal to 2. This guy is at t equal to 2. This guy at t equal to 0. Okay? Clear? So what is now? So maybe they want you to find the speed at t equal to 2 and the direction of the velocity. So this is if you want to find the direction, this is basically the direction. But you can also identify the angle of this direction, okay? So you have this vector. I want you please find the angle of this vector. The angle that makes with the positive direction of x-axis. So you have this vector v equal to -1 and 1.3. So v equal to -1 and 1.3. This is the velocity at time 2. So it's something like this, if you want to draw it. Not exactly. So what is this angle? Theta. So the speed, which is the magnitude of velocity, is a square root of 1 plus 1.3 square. Let me see. Which is about 1.6 meter per second. This is the speed. What about theta? So we know that tangent of theta is equal to what? 1.3 over 1. over negative 1, yes. Okay, so it's minus 1.3. So what is tangent? Be careful, when you use calculator, you take tangent inverse, what it gives you when you take the tangent inverse of this guy. Use your calculator.
We just set the radius.
Or arc tangent. No, just the degree and radian doesn't matter, but there is something I want to tell you, it's important. Tell me the degree, for example. The degree. So tangent inverse of minus 1.3 is negative 52. Okay, negative 52 degrees. But this angle is not negative 52 degree.
So when we plot to the calculator, we got the right angle. So
exactly.
So that's actually the other part. It's 180.
Exactly. So when you use calculator, they give you a theta between minus pi. I mean, for arc tangent, there is no pi half, but something like this. For calculator gives you this, but you know that. So let me tell you, this is important. So tangent is minus in this quadrant and this quadrant. But we know that this guy that we are looking for lives in this quadrant. Okay, so if this is like theta, and this also like minus theta, which is basically minus 25, this guy would be 180 minus theta, right?
It's which part? Set that. I mean, equation 2.
Yeah, I mean this guy. Let's say alpha. This guy. Let's see. So this alpha is 180 minus theta, right? Because this also is theta. Okay, so that means this theta is 180 degrees minus 52, which is equal to 128.
Yeah.
Okay. Now, what I want you for the last part of this question, I want you to find this, do the same computation for acceleration. Okay. Find the average acceleration. That's the part A, B, C. Let's say D. So for part D, find average acceleration in the time interval t equal to 0 to t equal to 2 second. And then E, find a general formula for instantaneous acceleration. Instantaneous acceleration. Okay. And compute the instantaneous and compute it. Compute acceleration. I mean instantaneous at t equal to 2. Okay. This is your job now. So the average acceleration so I just say average A is equal to V2 minus V0 over 2. But V2, so say this is V0, this is V2. V2 is minus 1 and 1.3. So let's subtract them. What you get when you subtract these two vectors. So minus 1 minus 0 is so first of all, you know this equation, let me just write completely, is delta V over delta T. So this is V2 minus V0 over 2. So what is V2 minus V0? Because when you subtract these two vectors, minus 1 minus 0 is just minus 1. This is the first component. What is the second component? 1.3 minus 1 is 0.3 over 2. So A would be equal to minus 1/2 and 0.15. A average. During the time 0 to 2. Okay. What is the instantaneous acceleration? So for instantaneous acceleration, you have to take the instantaneous velocity, which is this guy, and you have to take derivative again. So
But this one is instantaneous velocity.
Yeah.
And the derivative of instantaneous velocity is this instantaneous.
acceleration.
What about the derivative of velocity?
What do you mean by velocity?
I mean, so what I did is to.
This is generally, this dr by dt is velocity. By velocity, we mean instantaneous usually.
Oh, I remember. Just do the second derivative.
Yeah. So A, instantaneous acceleration, A is dv, the derivative of v with respect to t, which is equal, when you take derivative of, so here v, the first component is minus 0.5 t. The derivative of t with respect to t is 1. So you get minus 0.5, that's it, constant. So now you have 1 plus something times t squared. The derivative of 1 is 0, and the derivative of t squared is 2t. So you get 0 point, what is 2 times 75? 150, right?
Derivative of AX should be
Derivative of, yeah, derivative of t squared is 2t.
so the derivative of negative 0.5 t
Is negative 0.5. Right?
Remember the wrong formula.
So for those who don't know calculus, the derivative of, so in general, let me tell you, if you have t to the power n, t to any power, the derivative I denote by d by dt is n times t to the power n minus 1. For example, the derivative of t, d by dt of t is 1. The derivative of t squared is 2t, and so on. And when you have a coefficient, it doesn't impact the derivative. You just leave it, you just multiply it by. So here, for example, I have 0.075 t squared. What I do is I just take the derivative of t squared. And at the end, I multiply it by the coefficient, that is 0.075. Okay, so that is the acceleration. That clear? Now, now we want to compute the acceleration at time t equal to 2. So at time t equal to 2, then A would be minus 0.5. And what is the second component? 0.3. So what is the direction or the magnitude and the angle of this vector? So no problem. 149 is the angle. So I can draw this vector. Let me draw it in the xy coordinate. So you have minus 0.5 and 0.3. It's something like this. This is A. At time 2, of course, I just put A2. So the angle would be theta we know that tangent of theta, what is tangent of theta? Is 0.3 over minus 0.5. So theta is equal to, sorry, what you got? 100?
149.
149 degree. This is the acceleration at this time. And let's compare it to the velocity. Velocity was -1 and 1.3. Let me try to draw it here. The velocity is something like this, right? This is the velocity, v2. So the acceleration, a2, is minus 0.5 and 0.3. The velocity at times 2 is equal to -1 and 1.3. Okay, so another important concept is here. So the acceleration has two, we usually say it has two components with respect to velocity. One component that is parallel to velocity, one component that is perpendicular to velocity. Can you find the two components of the acceleration that are parallel to the velocity and perpendicular to the velocity? So let me explain this to you. So in general, if you have two vectors, I mean, forget about acceleration and velocity. If you have two vectors on the plane, say you have this vector like v, and you have this vector, which is u. Okay? So with respect to u, v has two components. One is the one that is parallel to v, to u. So this guy, I call this v parallel. I denote it by v, double line. There is another component perpendicular that is perpendicular to u. So I denote it by v perp. V perp and v parallel. You see, so if you have two vectors, you can decompose one of them in two components. One is parallel to the other one, and one is perpendicular. Do you know how to do this? So basically, if the angle is, you need the angle theta, right? If the angle is theta, then v parallel is equal to magnitude of v times cos theta. And you can say, basically, once you find the v parallel, and this is very important, once you find the v parallel, you can you know that v parallel plus v perpendicular is equal to v. So v perpendicular is basically v minus v parallel. So once you find the v parallel, you just subtract it from the total v, you get the perpendicular part. You see? There's a trick. Yeah, I mean, V absolute value magnitude of V is, you can say that it's V perpendicular square plus that square. But we don't use the Pythagorean. He said, do we use Pythagorean? I said, no, we don't need to use Pythagorean.
Why? Which angle is the 90 degrees? So
And theta is the angle between V and U. So you have two vectors like this. Okay. So you want to find the parallel component of the red, which is this one, and the perpendicular component. Okay. So here, write it here. So the V parallel, if you want to find the vector here, let me just write it here. Then you have to multiply it by U and divide by magnitude of U. Because here what I wrote is just the magnitude of the V parallel. But the vector is in the same direction of U. Okay, so you have to multiply it by the unit vector in the direction of U, which is U divided by magnitude of U.
but the perpendicular one, why we can't just subtract?
Because this plus this is this. This vector plus this vector.
Oh, we calculate the vector one, so we can just simply add.
Yeah.
But if for the magnitude, we cannot just.
No.
Oh, I see.
Sorry, that was my fault because I wrote the magnitude, not the vector. But here I mean the vector. Okay. So let me do just some examples. Okay, just to understand this concept better. So imagine, let me just give you two vectors. Imagine that you have one vector V or U so imagine that this is U and we have another vector V U is equal to 5 and 1 and V is equal to 2 and 4. Okay. So here I want to decompose V into two vectors. One is parallel to U, another is perpendicular to U. So that is our goal, to decompose V in two components, which are vectors. One is parallel to U. So I call this V parallel. And one is perpendicular to U. I call this V perpendicular. So let's find these two vectors. So first of all, I need to find the angle between U and V. So what is the angle between U and V? So first tell me, what is the angle of U with respect to the x-axis? So if these are two axes, what is x and y? What is the angle of u?
11.3 degrees.
You sure?
The tangent.
Okay. 11.
0.3.
Say 11.
Yeah.
That's fine. So I trust Howard. The angle is 11. This is theta is equal to 11. How about the other guy, V? Can you compute the theta for V? I mean this angle, this green angle.
63.4.
Say 63 degrees. Okay. So that means the angle between U and V that I call alpha, this angle, so this angle alpha is equal to what? The angle between U and V. 63 minus 11 is equal to 52. Okay. Now I want to find the V parallel and V perpendicular. V parallel is just, so I told you that V parallel is just absolute value of V times cosine of alpha, I mean this alpha, times the direction of U. Direction, I mean the vector direction of U. The vector direction of U is U divided by the magnitude of U. This guy is basically the unit vector in the direction of U. Okay. So what is the magnitude of V and magnitude of U? Magnitude of V is square root of 20 and then cosine of 52 degree times U, which is 5.1, divided by magnitude of U. Magnitude of U is a square root of 26, right? Okay, tell me these numbers. What you get? What is the coefficient here? Square root of 20 over square root of 26 times cos of 52. Lisa, you tell me. You tell me. What is this? This coefficient.
Yeah, the coefficient is 0.54.
0.5?
4.
Okay, so this is equal to 0.54 times 5 and 1, which is equal to
2.7.
2.7 and 0.50. So this is the parallel component of V with respect to U, and the perpendicular component is just V minus this guy. Okay, so V perpendicular is just V minus V parallel. Okay, so in general, here is the formula for the parallel and perpendicular components. So getting back to our original question, so here I want you to find the perpendicular and parallel components of the acceleration with respect to v velocity. For this question, please do this. This is your assignment. Okay? The parallel and perpendicular components of the velocity vector with respect to acceleration at this time t equal to 2. So you have these two vectors, velocity vector, acceleration. Find the parallel and perpendicular components of acceleration with respect to velocity. Okay. So the question is to find A2 parallel and A2 perpendicular with respect to V2. Parallel and perpendicular parts of acceleration with respect to velocity.